Python conditional logic is managed through one key statement, the if statement, as well as two optional statements, the elif, which is a shorthand in Python for else if, and the else statement. We can create a bunch of conditional logic just using ifs, but these other kind of chained conditional statements allow us to limit the processing requirements of our logic, as well as allow us to kind of curate how the logic is processed in different ways. Let's take a look at how this is structured. In Python, to create an if statement, we simply type if and then the condition that we want to check. So something that I might say here is if 2 is less than 3, and then a colon. When I hit enter, the next line, and any line along this level of indentedness, will be the content that exists inside of this if statement. So if this condition is true, anything inside of here will run. This content will run. And once I indent back out, I'm out of the if statement. The indentation contains the content. So if I'm just going to say if, well, I want this to be indented here, if 2 is less than 3, math still makes sense. And let's just run this here, and indeed, math still makes sense. Perfect, wonderful. I'm glad to know it does. Awesome. To make a program here, let's get a bit more interesting information that's going to be a bit more variable. For example, I'm going to assign this age variable the value of the input from a question that I asked the user. What is your age? Or maybe a less awkward way of saying it, how old are you? Let's go with the way we actually might say it in the real world. And I might just check if age is less than 20. I'm going to have an error happen this first time I run this, however. Let's run this. It says, how old are you? What if I say that I'm 15 years old? I get an error. Less than not supported between instances of string and int. Oh, right, we've dealt with this before. My age variable is being interpreted as a string because the input kind of automatically gathers string type data, but then I'm comparing it to a number, an integer value. I need age to be considered an integer in this context, so I'm simply going to cast it to int after gathering it from the user. Now if I run my program and I type in 15, math still makes sense. Now this is not a sensible response for this. I'm going to say, you are still young. Congrats. You are still young. All you youngins watching this video probably. You're still young, congrats. And here we go, a full if statement complete. Let's create a second one just to make sure that we're on board with this. I'm going to also say if age is less than 0, then that means that, well, I'm being trolled here because that's not a viable age. Maybe you have not been born yet. Weird. And let's just check this out. How old am I? If I type in 15 again this time, it just says you are still young, congrats. This condition is met as true, so its content is accessed and dealt with. However, the second condition is not true. This fails to succeed, therefore its contents are not run, and it aren't run down here. But if I run this again and I say I am -5, we'll see that both messages print out. You are still young, congrats, because the age is less than 20. And then I'm going to check the second statement, and I'm less than 0 as well, so I've not been born yet. Weird. Maybe I want to actually consider having this run in a way that doesn't print both messages if I'm less than 0. So how could I do that? Well, the first thing I'm going to try to do here is just move this first condition ahead of the first one and introduce my first logical chain, my elif. This just means else if. And the way that this functions is I say if this, and if I check this and it fails, then I check this afterwards. However, if this succeeds, this is skipped entirely. So success, I move on. However, if this fails, I check this one. If it fails, I move on. If it succeeds, I perform its internal functionality. So let's just see. If I type in -5 this time, I see I've not been born yet, weird. But this statement doesn't run. Even though it's technically true for this input of -5, the elif means it's not reached because it short circuits is what we call it. It doesn't process the next piece of logic because of the chained nature of it. However, if I run this and I say I'm 5 years old, you're still young, congrats, This fails, so it moves on to the second one for the check. And I can chain as many of these pieces of logic along as I want to. I can just say the ELIF age is less than, I don't know, what's the median age? Roughly about 42 right now. I can say you are not yet middle-aged, which is great. I'm in this situation right now. I'm not yet middle-aged. I'm still fairly young. I'm 34. I'm not yet middle-aged. And only this one was run because, of course, it didn't meet either of these conditions in this conditional logic. So only the third one is resulting here. I can actually add a final situation. What if I wanted to check anything 42 and above? I wanted it to all have the same response. Well, that's where the third type of condition comes in, else. And what else does is basically says, if this and this and this failed, then this has to run. It covers every other possible outcome. And here I'm just going to say, yeah, you old. So if I type in the age 43, yeah, you old runs. And it doesn't matter how big a number I type in. I could be, I don't know how, maybe like 10 million looks like, maybe at a glance there. Yeah, you old, if that's the number that was printed out. So I have my three different types of conditions here. If, else if, spelled elif, and else, that deal with these three different scenarios of logic. And I could, if I wanted to, kind of have another set of another if statement of some kind. I could check over here, maybe a separate thing, like maybe age is less than 20. I can just say, once again, print, you are still in grade school. Yeah? Maybe actually that's less than 18 itself. Let's say 19, just to be specific. I have some 18-year-old students. How old are you? If I said 18, you're still young, congrats. You're still in grade school, yeah? Because this first chain has one of its solutions printed out, but now I have a new chain forming. I can maybe do another elif after this and check something else for a different age range if I wanted to. So I can totally have different conditions in a row processing the same variable, no problem. But I want to show you one more thing in this context here, which is, what if I wanted to tighten this up a little bit more and say something in a particular range of things in a little bit more of a condensed way? Well, I could say, if age is less than 0, you've not been bored yet, weird. And I could say here, if age is greater than or equal to 0, and age is less than 20. You are still young, congrats. So I've chained together two conditional statements. On the left, if age is greater than or equal to 0, and on the right, and age is, oh, I meant to say less than 20. The logic would have been kind of funny coming out there, and less than 20. Meaning from ages 0 to 19, because 20 isn't included. So I can actually include kind of both of those conditions on the same line by chaining them together with AND. So let's see how this runs. It should just run the same as before. I'm 18 years old. You're still young, congrats. Was processed just fine using this chained logic. However, what if I just wanted to not allow certain age ranges? Maybe I'm kind of importing some information into a program that recognizes ages from 1 to 100. So I want to say, if age is less than 1, or if age is greater than 100. I have two situations here, anything less than 1 and anything above 100. I've covered both of these kind of outer, not really realistic age ranges for people. And maybe in here I say something like, incorrect age. Please choose one that works. Or choose one that's honest. Maybe so. Why I want to say this? Oh, I got an escape character here. That's honest. So, and end my string. So please choose one that's honest. And now in my program, how old are you? If I say I'm -1, please choose one that's honest. If I say I'm 101, please choose one that's honest. Maybe I want to be a bit more lenient on the top end just to be optimistic about our futures. But here we have the OR linked together, which allows me to have one of two states be reached. Clearly, 101 is not less than 1. But this still is marked as true because with an OR statement, only one of the conditions has to be met. And since this one was met, it printed it out. And so we have a few different options here. One more time, we have our three different setups, else, else if, and else, for different types of chaining and different types of conditional statements. And then within any conditional statement, we can have as many conditions checked as we want. And we join them with and or, depending on how we want our logic to be chained together.